Tests involving organic substances. Welcome. We start with the combustion test. So common expected observations and correct inferences are as tabulated below when it comes to combustion test. 1. We can provide you with an organic substance which can be a solid or a liquid, and then we ask you to burn the same. So if we see that the solid or the liquid burns with a blue non-sooty flame, the inference would be that the functional group for the alkenes, that is carbon-carbon double bond, or the functional group for the alkynes, carbon-carbon triple bond, this time round is absent. Now, writing that alkane, alkene, or alkyne is either present or absent will not be acceptable. We only allow the functional groups for the different homologous series. Carbon-carbon double bond, functional group for the alkenes, and carbon-carbon triple bond, the functional group for the alkyne. We continue with combustion tests. This time round, our solid or liquid will burn with yellow sooty flame. When we observe that our solid or liquid provided burns with a yellow sooty flame, then we shall infer that the functional group for the alkenes, the functional group for the alkynes are present. Now, instead of using the two, we are also allowed to infer that unsaturated organic compound is present. Unsaturated organic compound is present. This can also be substituted by the words that organic compound with high carbon-hydrogen ratio is present. And we also allow long-chain organic compound being present if we see solid or liquid burning with a yellow sooty flame. Now, on the same inference, we shall not accept alkene, alkyne present. If a candidate wrote that, that is not allowed. As we have said earlier, we only allow the functional groups for the same. And a candidate who talks about long chain hydrocarbon will also be wrong. We only allow long chain organic compound, not long chain hydrocarbon. We then proceed to our test number 2 after combustion test, and this is solubility test, where now we put our substance in water, or we add water to our substance. When we add water to our substance, we are likely to make two observations. One, our solid may dissolve to form a colorless solution. If it is a liquid, then the liquid may dissolve to form a uniform or homogeneous solution or mixture with water. And we might also say that the liquid is completely miscible with water. If that is the case, a candidate is expected to infer that the substance provided is a polar organic substance or compound. We don't allow hydrocarbon because we know that most hydrocarbons are actually immiscible with water. Now the next expected observation is that our solid will not dissolve, and if it is a liquid, then it will be immiscible with water. If that becomes our observation, the expected response is supposed to be that the substance provided to us is actually a non-polar organic substance. We now proceed to a test where we are asked to add either solid sodium hydrogen carbonate or sodium carbonate in solid state, or aqueous sodium carbonate, or even magnesium ribbon. So in tests where we are asked to add these four substances, the most probable observation would be effervescence, which can be replaced with the word bubbling or fizzing. But we are being told that hissing, sizzling, fizzling, or colorless gas produced, all these are usually rejected. So if we make these observations, then our inference is supposed to be that RCOOH is present. This usually represents the alkanoic acids. Now, instead of writing RCOOH, we also accept that carboxylic acid or alkanoic acid when written in words instead of these functional group here. If a student also mentions that either hydrogen ions or hydroxonium ions are present, that is also allowed. We also go ahead to allow a student to write that the solution is acidic. All those are allowable for correct inference. Let us now proceed to addition of our oxidizing agents, that is acidified potassium manganate 7 and acidified potassium dichromate 6. So when we are asked to add acidified potassium manganate 7, we also have two sets of possible observations. The first set is that the purple acidified potassium manganate 7 changes to colorless or decolorizes. The word here is changes. The examiner has since denied using the word turns. So candidates, please take note. And on the same note, if we see this kind of observation, this is the only way a candidate is supposed to express it. All these other ones in red are going to be rejected. The first one being that purple acidified potassium manganate 7 turns colorless. Turns is not acceptable because turns seems to be a physical process. Some other candidates also observe solution turning colorless. So we do not know which solution this is. Potassium manganate 7 is decolorized, is also not allowed because you have to give us the original color, which was purple. Potassium manganate 7 turns colorless or decolorized again is not allowed because the original color is missing. So if this correct observation has been made, a candidate is supposed to infer that either the functional group for the alkenes or the functional group for the alkynes or the functional group for the alkanols is present in your compound. We move on to the next set of observations where this time round the purple color of potassium manganate 7 persists or is not decolorized or remains. This is the correct observation. If a candidate writes that the solution remains purple, that would not be accepted. Solution is not decolorized, again is rejected. Purple color persists, remains, or is retained, not acceptable. Color of acidified potassium manganate 7 persists, remains, or is retained is not acceptable as well because here the original color is missing. Finally, a candidate who writes that the color of acidified potassium manganate 7 does not change to colorless is also not given any mark because the original color, purple, is missing. So the correct inference for this observation now would be that the same functional groups for the alkenes, for the alkynes, and for the alkanols, this time round they are absent. And that is why the purple color of acidified potassium manganate 7 is persisting. We now proceed to the next oxidizing agent, which is potassium dichromate 6, of course acidified. This reagent basically tests for presence of ROH group. So it also has two sets of observations that are expected. One, orange acidified potassium dichromate 6 changes to green. That is the most appropriate observation. Any candidate who says that orange acidified potassium dichromate 6 turns to green is wrong. Orange acidified potassium dichromate 6 turns colorless. This is a wrong end color. Solution turns green, as we've agreed, is not acceptable. Acidified potassium dichromate 6 changes to green, lacks the original color. So if we see this observation, obviously our organic substance contains the ROH group. The other set talks about the orange acidified potassium dichromate 6 persisting or remains orange. The sets of observations that are rejected include solution remains orange, solution is decolorized, orange color persists, remains, or is retained, color of acidified potassium dichromate 6 persists, remains, or is retained. What color is it? The color is missing. And lastly, color of acidified potassium dichromate 6 solution does not change to green. Give us the color. So if this is the observation, a candidate is supposed to refer that this time round ROH is absent. Next, to bromine water. When it comes to bromine water and a candidate notices that the yellow, red, or orange bromine water is decolorized or changes to colorless, the inference would be that the functional group for alkenes and the functional group for alkynes is present. Now, the observations that are rejected include the yellow, red, or orange bromine water turns to colorless. Turns is physical. Solution is decolorized, is not allowed. Bromine water decolorized or bromine water is discolorized. All those are not acceptable. For the negative, we have the yellow bromine water persisting, is retained or remained. This time round, the two functional groups that are up here, we shall infer that they are now absent. Again, we have a set of disallowed observations. Solution remains yellow. Yellow color persists, remains, is retained. Color of bromine water persists, remains, or is retained. Or color of bromine water solution does not turn or change to colorless. All those are incorrect observations. Let us now proceed to esterification. So for esterification, 1 cubic centimeter of 2 molar sulfuric 6 acid will be added to the substance, followed by 5 drops of ethanol. This case we are testing for RCOOH, or 5 drops of ethanoic acid when we are testing for ROH. For this test, we may be asked to warm as well. So we expect pleasant, fruity smelling or smelly compound to be formed. Now, we reject smelling compound formed or sweet smelly. Sweet here is for taste. It can never be smell. Smells are never sweet. So for the inference, if we observe this, either RCOOH is present or ROH is present, of course, depending on the test that you are asked based on the above description. Let's finally look at the use of universal indicator on organic substances. So while using universal indicator, we are being warned that only one value for pH should be given. If we give a range as candidates, we are not going to get the mark. But for this illustration, I want to give a range because the inference for pH value of 1, 2, and 3 will be the same. But for a candidate, please pick only one value. So if you have a value between 1 and 3, we will infer that your compound is strongly acidic. If you have any value between 4 and 6, though give us only one out of that range, we will talk about your substance being weakly acidic. pH 7, of course, this is for neutral substances. 8 to 10, weakly basic. And finally, 11 to 14 is strongly basic. With that, we are through with this short video where we have taken our candidates through how to write observations and how to infer from these observations when carrying out tests on substances that are organic.